Hi everyone, how are you doing? So today we will be discussing the rest of the questions that we were doing, right? Okay, so let's get started. Now let's solve this question. So if we are saying that Fn, right, Fn is less than equal to this Gn, then Fn is also greater than equal to Gn. What do you think? If that's the case, I mean, if this is true, then can we say if it is also big omega? I don't think, right? So this is not true. So that's why we will say this is false. I think this is false. What about this? Yeah, that's nice. Let's just try solving this. This is 4 power log base 2n, which means this is, can you exchange this n and 4? I mean, you can also write it n power log base to 4, right? Do you recall that property? That if you are having a power log base anything, okay, b, then this is also b power log the same base a. Okay, I mean, you can exchange this base and exponent. Okay, so that is why this is just n square. So this is n square. N square is greater than or equal to n. Yeah, that is true, right? That is true. Let's just see this C option. Now let me go to the next page to explain this C option. So suppose they are saying something like this. Then let's just see if it is true or false. See, this is 2 power log base 2, log base 2, log base 2 n. Okay. What we can do here? What we can do? This is 2 and log base 2 will get cancelled out, isn't it? So, I mean, this is same, so you can just cancel it out. So this is log n. This is just log n. I mean, you can put the base, doesn't matter. This is log n. And can we say log n is basically greater than or equal to n? No, right? Okay. By the way, do you understand this log n is, what do you think? It is small or very small, or I mean, what do you think? How small it is? Yeah, it is very, very small number. Okay. I mean, obviously, like we cannot say it formally, but in almost all practical applications, this is same as constant. Okay. Why I'm saying this? I mean, this is not true formally, but in almost practically, in if I talk about practical sense, this is same as constant. What do I mean by practically? If even if n is too large, even if n is, let's suppose n is let's suppose 2 power very large, let's suppose 2 power 64, which itself is a huge number, right? 2 power 64. Even if in that case, then what is log n? The 64 is 2 power 6, right? So this log n is just 6. So basically, even though n is too large, even though in practical sense, like I don't think our input size can be that much large, even though it is too large, still this log n just very, very small number. So that is why, I mean, in practical sense, I can say this log n is constant. Log is reducing your numbers too drastically, isn't it? But yeah, I mean, this is a function. It is not a constant formally, but in practical sense, I'm saying it is very, very small number. Okay. So this is false. What about this? Do you remember? We have seen this yesterday. This is true or false? What was the answer? This is also false. Yeah. So I think the only B option is true. So this is true. This is false. This is false. This is false. So only B option is true. Right? Okay. Now let's see question number 27. So if Tn is, they are saying if Tn is less than or equal to Gn, then Gn is greater than or equal to Tn. Can you say this? Do you understand this this notation? I mean, why it is a belong notation, why it is not equal notation? Do you understand this? I mean, sometimes see, sometimes we write equal notation also, sometimes we write this belong notation. So what are the difference between these two? Which one is, by the way, which one is more formal? Writing this equal or writing this this belongs to notation? More formal. Are you sure? This is a function or this is a set of function? This is a function or this is a set of function? This is a set of function, right? I mean, if you are writing, let's suppose order of n square, then it means it is a set of all functions which are basically less than or equal to n square, maybe n log n, maybe 2n square, maybe 3n, right? This is a set of all functions. So we should be writing block notation, but we can abuse the notation. Have you seen that particular video that I have uploaded? Right? You can also abuse the notation. The video title was formal asymptotic notation or something like that, right? So basically, just for our convenience, we write equal to. Otherwise, they should be belong. I think there was yeah, you can abuse the notation, but you should not misuse it. I think there was this year, or I think last year, there is one question in GATE also, and the question was actually related to this belong notation. I think this year or last year. Don't remember exactly, but yeah. But anyway, like we have taught it before Gate has asked. Okay, that's what I'm sure. So even when like generally what happens in other coaching institutes, like they do generally what I mean, they generally analyze the previous year questions, and they set their material in such a way that you are able to solve the previous year questions. I mean, they know that okay, if we teach these things, then you are able to solve the previous year questions. But we don't only do that. I mean, that is the one thing, but we don't only do that. I mean, our course material is not just to solve previous year question. Our course material is to solve the new upcoming questions also. So we have already taught it even before the Gate has asked these differences. Okay. So this Tn belongs to order of Gn, and then Gn is belonging to order of this big omega of Tn. Is this true? G is not a set of functions. G is Gn set of function? Is Gn set of function? Order of Gn is set of function. Yes. Okay. This is a set. G is not a set. Yes. Yeah. That order is set. This is always set. I mean, these things are always set. Okay. This is, I think we have already seen this. There is some property that I told you that this is true, right? This is true. What about this? If that is the constant, if you're multiplying the constant, if you're not multiplying the constant, I don't think it will matter, right? Both sets are equal. So this is one set, this is one set. You multiply with a constant, then it won't matter in the asymptotic notations. So that's why this is also true. What about this? That's interesting. So what do you think? True or false? That's also true. Why? Because this is saying greater than equal to, this is saying less than equal to, or I mean, in whatever sense you want to take. So order of Gn means that all the functions which are less than equal to Gn, right? So maybe you can write less than equal to Gn. So all the functions which are less than equal to Gn, all the functions which are greater than equal to Gn. And then if you take the intersection which are equal to Gn, so it is true. Okay. Let's see this. For any two non-negative functions, Gn and Tn define a set of the non-negative integers. Either Tn is this or Tn is this. Okay, which means Tn is either greater than equal to or less than equal to. What do you think? Is this true or false? So if you take two functions, either Tn less than equal to Gn or Tn greater than equal to Gn. So we have already seen this. This is false, right? So we have seen the examples earlier also. So this is false. One of the example is this, right? If that is the case, then you can't compare both of these functions. I mean, it is not always the true that Tn is less than equal to Gn. Sometimes Tn is less than Gn. I mean, if it is even, then Tn is less than maybe. If it is odd, then Tn is greater than Gn, right? Okay. Let's see this. Yeah, that's interesting. So 2 power log n square. So here you need to just apply the log properties. So that's interesting. Let me go to the next page. 2 power log n square. Can I rewrite it like this? 2 power log n You can basically multiply these two, right? So this is log n square. Can I rewrite like this? I think we can rewrite like this, right? And let's assume that log base is 2, as I told previously in the first slide itself. Okay, see that here we are assuming that log base is 2. Okay, cool. So assuming that log base is 2, now tell me what is this number? This is n, right? This is n, and n power, you can say this is n power log n. Okay. So this is n power log n. This is n power 1.5. Is this correct or there is something wrong? I think this 2 power log n square can be written like this, right? There is not an issue. Yeah, that can be written like this, and this is n power log n, and that is n power 1.5. So which is greater? Obviously n power log n, right? Because in the if you are comparing two functions such that n power something, then you can just compare these powers. Whichever power is greater, you will say that function is greater. So n power log n is greater, right? So this is n power log n, which is greater. So since it is greater, that is why you cannot write like this, right? So this is false. I have taken this question from Washington University. So this question, this particular statement is false. I hope you are able to do that, right? Now let's see this. Let's suppose we want to compare all of these functions. So one function is this. Now you can ignore this. I mean, this is just you can say that this number, this 17n is negligible with respect to this n power 4, right? So basically, this is a polynomial in n power 4. This is a polynomial of n power 7. So finally, it is n cube, right? This is n cube. This is n log n. This is something lesser than n cube, right? I mean, n cube, something lesser than n cube. And then this is 2 power something. So let's just see if we can basically simplify this. Can you simplify this? If log base is 2, how can we simplify this? So this 3, you can take this 3 to power, that's okay. But what else? See here. See, whenever something like 2 power something is given to you, then it is best if you can write something like this, log base 2 and then something, so that you can just cancel out these two, right? So you can take this 3 into power, that is okay. Power of this log, but what else you can do? Maybe what can I do? We can take this 3 log n, this whole thing, to be a power of this log n, isn't it? So I think it is better. It is better if we can take this. This is log n. Okay, log n power 3 log n. Right? I mean, you can take this 3 log n outside and then you can match these two. Now you can just cancel out. It is log n power 3 log n. Okay. And what is the other function? Yeah. So this is log n power 3 log n. One function is n cube. Another function is log n power 3 log n. Another function is n log n. Another function is something lesser than n cube. I mean, n cube upon log n square. Now I need to compare all of these functions. Let's just compare between first two. Which one is greater? What do you think? Which one is greater? N cube is greater, or this log n power 3 log n is greater? So if you take log, then maybe we can compare. If you take log, this will be log n, 3 log n, right? This will be 3 log n. And then this will be 3 log n multiplied by log n, isn't it? If you take log, then it will be 3 log n multiplied by log n. Now, obviously, this is strictly greater, right? This is strictly greater. So I think log n power 3 log n is strictly greater. Okay. So you can say that log n power log n, so log n power 3 log n is strictly greater than n cube. So this is the greatest one because this is n cube, and this is the greatest one. Let's suppose this is f2, this is f1, this is f3, this is f4. So let me now arrange all of these functions in the increasing or decreasing order of the growth. Okay, so tell me which one is the greatest one. You can easily identify that f2 is the greatest one, and then f1, and then like we need to compare between n cube and, so this is basically n cube, this is log n power log n, okay, I mean log n power 3 log n, and which is the greatest one, then n cube. Then what do you think that among these two, which one is greater, n log n or n cube divided by something? Intuitively, can you tell me quickly? I think f4 is greater, right? f4 is greater. Why? Because this is I mean n power 3 minus something. I mean, even if you remove something, even if you just say that, okay, I mean, if you remove something, right? I mean, if I just rewrite it like 3 minus epsilon into 3 n power epsilon, something like that. So basically, this itself is basically a good function. So n power epsilon itself is a greater than log n square. Even though if I just cancel out, I will say that, okay, these are equal. These are equal. I mean, this log n square won't be doing much harm to this n cube. Yes, it is doing some harm, but not that much harm that it is even lesser than n log n, right? So, so now you will say f4 and then you will say f3. log n is anyway small, स्क्वायर करेंगे तो no square करने से तो that is a good function. I mean, but it is in a denominator, so that's why you can say it is a I mean, it is doing more harm, but that is okay. I mean, see, this is n cube divided by log n square, so some small fraction of the n will just compensate this log n square, right? It is still the n cube minus something, right? Some small fraction of n will compensate this log n square. So it is in fact greater than n square, right? Tell me this n cube upon log n square and n cube, which one is greater? Obviously n cube is greater, right? Now tell me n square, which one is greater? Which one is greater? This first one or second one? First one, right? Because this is same as saying n cube minus some small thing. You just remove some small thing. I mean, some small power, right? That will compensate this. And I mean, if you write this, is, you can write it something like this, right? Some small power, and this will compensate this log n square, because this log n square and n power epsilon, anyway this n power epsilon is greater, right? So some small power, let's suppose this is 0.0001, then also this n power epsilon is greater. So basically this is same as saying this above function is same as saying this is n cube minus epsilon, where epsilon is negligible. Okay, epsilon is negligible. You can say something like this. Okay, so that is why you will say this is greater, right? So if I ask you between these two functions, suppose if I ask you between these two functions, then which one is greater? So instead of 2, it is 2.5. So Twinkle is saying she is taking n as 8. So like, I mean, which method you are applying? I have never ever discussed that take the values of n. I never suggested this method. So don't take the values of n and then compare. It is the asymptotic comparison. So if you are taking, then actually you might be unlucky if you are taking. So that's the problem. Okay, and if you're taking, then take very large values, something like this. Okay, something like this. I mean, most probably that the turning point, if at all the turning point exists, it will be before this. Okay, it will be before this, because the asymptotic comparisons are after turning point. Okay, so all the asymptotic comparisons are after turning point. as we have discussed, right? So we want to discuss the asymptotic comparisons after turning point. Then only we say this is greater or this is lesser. Before the turning point, we never talk about the asymptotic comparisons. Okay, here's anything can happen. So first of all, you should not take the values, but by chance, if you have to solve the question and there is no other way other than taking the values, then take very large value. Maybe something like this. Take very large value, 2 power 64. Okay, then also you might be unlucky, which means most probably if you're taking 2 power 64, this will be here. I mean, at that point, the asymptotic comparisons are valid, most probably. But suppose you are unlucky, then it means what? 2 power 64 is even before your turning point. It might so happen. Okay, if you're too unlucky, then your large values are could be before the turning point. So that is why don't take the values. Even if you're taking, then take very large values, and also take, I mean, 2 3 very very large values. 2 power 64 is obviously very large. You can also take 2 power 1024, something like this. Okay, take large values and also take multiple large values. If you are taking the values, actually I don't suggest to take the values because it is not a good way to do that. But if you're taking the values due to due to there is no other choice in the exam that is left to you, then take very large values and also take multiple large values. Okay, so which one is greater? 2.5, n power 2.5, and this first function, which one is greater? What do you think? Again this, right? Again this. See, the first function is n power 2.9999999. The first function is this. Okay, because you have just removed very very small fraction that you can't even measure. That just a small fraction. This log n won't do anything. Log n square will be just taking very small fraction. That's what I'm trying to say. Okay, so I mean, actually, anyway, okay. So I hope that is clear. So what I'm saying here is that, like, if you're taking any power something like the 2.5 or something, then it will be lesser only, because this function is anyway very close to n cube. This log n square is not doing much harm. That's my point. Okay, log n square is not doing much harm. Why it is not doing much harm? Can anyone tell me? Because n power epsilon is greater than log n power k. We have seen this, right? Asymptotically, this is greater, strictly greater, which means even this is log n square, then very small power itself is greater. Very small power. I mean, n power 0.0000001. Very small power itself is greater than log n power log n square, right? Log n square. So this log n square won't do much harm. That's my point. Okay. So I have given the solution already here. So this is a good solution. If you want, you can go over this, right? Okay. Now let's solve this question. So this is n square. This is n power log 16, which is again n power 4, right? This is n power 4. How? Because this 16 power log n is n power log 16, which is 4. So that's why it is n power 4. This is n power 4. So the first function is n. Second function is n power 4. Third function is 2 power n plus this thing, right? Which is 4 power n by 2 plus 2 power n. Okay. So what can you say here? Which one is greater? I mean, this 4 power n by 2 is what? See, this is okay. This is coming out to be 2 power n. Why? This is 4 power n power 1 by 2, right? So, I mean, these are the two powers. You can even exchange the powers. I mean, anyway, no, like you are anyway going to multiply the powers. So this is also 4 power n by 2. This is also 4 power n by 2, right? So you can exchange these powers. So which means this is 2 power n. right? Both are 4 power n by 2. Like even if you exchange the powers, then also it is 4 power n by 2. If you don't exchange, then also this is 4 power n by 2. So basically both are 4 power n by 2. So you can say it is 2 power n. So this thing is just 2 power n. So the third function is just 2 power n. Fourth function is 3 power n. Fifth function is n cube log n. What do you think? Which is the greatest one? Let's suppose this is f1, f2, f3, f4, f5. Which is the greatest one? F4, right? I mean 3 power n. Okay. And then I think 2 power n. Then I think n power 4. Then n cube log n. Then n, right? Okay. So that was easy question, I think. This is. Have you understood this? I mean, once you just simplify all of the functions, then the ordering is very much trivial. Okay. So do you have to do any mathematics to compare between 2 power n and 3 power n? Or you just know this already? Let me know. Or you are solving it all every time you see these two functions. I think you know this, right? You can divide by 2 power n both sides, and then you can check that one is 1 and another one is some function. So which is 1.5, I mean 1 and 1.5 power n. I mean if you divide by 2 power n both sides, it will be just 1. It will be 1.5 power n. So basically you can say that another one is some function. This is constant. It is strictly greater. So basically if it is a base, if the base is greater, then the function is greater. Okay. K can't be a function in log power k. No, k can't be a function. I mean, if that is a function, then you have to do it differently. Okay. So yes, that's a nice doubt. I think at one of the place we did it, right? Yeah, here, right? So k can't be a function. If log n power log n, as we have seen, is greater than n cube. Okay. So this is just cube. I mean, this finally this number is greater. So k can't be a function. It's not like that k will. It's a good doubt. And then the counter example is here. A counter example or example, whatever you want to call. Okay. Now let's just see this. Yeah, that's one interesting question. Have you solved that in the first go? So they are saying fn plus small o of fn. What does this mean? So if you are putting fn, then you are putting greater than fn, right? Something greater than fn. Strictly greater than fn. Then can it be just theta? Tell me. See, fn plus something strictly greater than fn in terms of asymptotic comparisons. Can it be theta? Okay, just take a few seconds and then try solving this question. Actually, I misguided you just now. Okay, so just forget about it and just take few seconds. I want you to solve that. Okay, just see this and try solving this question. So try your own and let me know what is the answer you're getting. True or false? Yeah, that is true. Why? Because whatever function you take here in place of this, that will be strictly lesser than fn, right? Let's suppose gn is small o of fn, right? Gn is small o of fn. Then you are going to put gn here, which means this will be fn plus gn. And gn is strictly lesser than fn. So if you are putting strictly lesser than fn, you are not putting greater than fn. Okay. You're not putting greater than fn. You're putting strictly lesser than fn. If you're putting strictly lesser than fn, you can definitely ignore it. So this is just theta of fn. Right? So many students may get this answer wrong. Okay, many students. So that's why, like, I mean, this this big small o seems like that you are putting, you are definitely putting greater than fn. No, inside this is, it is greater than. I mean, this quantity is greater. Okay, whatever you are putting is actually lesser than this quantity. So if gn is or small o of fn, and if you're putting gn here, that it means it is strictly lesser than fn. Okay, I have given the solution on the next page. It means gn is strictly lesser than fn. Okay. Now let's just see this question. For any constant xy, we have n power x, which means they are saying if it is greater than 1, then okay, we have seen something like this, to n cube and 2 power n, right? We have seen these things. Do you remember? Which one is greater, n cube or 2 power n? I think 2 power n. Okay. Now they are asking you to compare between, let's suppose they are asking you to compare between n power, any power, okay, I mean anything, and then here any other constant, maybe epsilon, not epsilon, sorry, 1 point something. I mean, that should be greater than 1. Okay, some c power n. Okay, where c is greater than 1. Let's just compare between these two. So we can take the log. It will be k log n. It will be n log c. Okay, c is greater than 1. If c is less than 1, then it will be even negative. Okay, c is greater than 1. Then which one is greater? You can ignore the constants. You can ignore the this and this. Which one is greater? This is strictly greater, isn't it? This n is strictly greater. So that's why the original functions are strictly greater. So basically, any, I mean, if that is greater than 1, so either you take 2 power n, you take 3 power n, or here you take n power anything, that is strictly greater. Okay, this is strictly greater. I mean, you can also verify it. It's not like that you need to remember it. So is this true? Tell me. Since it is strictly greater, I think this is true, right? See, this is 2 power n, or anything you take here. If it is strictly greater, then I think this is true. So maybe this is true. Okay. Is this okay to everyone? Okay. Okay. Now let's check this. First of all, these kind of functions are incomparable. Okay, no, actually that's the trick here. If it is n power sin n, then it is incomparable, but it is n power, I mean 3 plus sin n, and sin n can range from -1 to 1, right? So this function can this f3, sometimes is n square, and sometimes is n power 4. Sometimes n square, sometimes n power 4. Okay. This is n power log n. So I think this is too much, right? Whether it is n square, n power 4, n power 1000, anything, this n power log n is too much. So I think this is greatest. F1 is greatest. This is square root of n. Even in the worst of this, n square, this is greater, right? In the worst of this is greater. This is n log n. So tell me, n log n square, even you don't take this n power 4, or then you can compare. N log n square, and square root of 1. Which one is greatest? N square, right? So n square is greatest. And then n log n. Sorry, yeah. Now tell me, square root of n or n log n? You can divide by square root of n, and then you can check that n log n is greater, right? Obviously, like this n itself is greater than square root of n. So that's why this f4 and then f2. 1, 3, 4, 2. Okay. Even if you take the worst of this, I mean, even if you say that, okay, this is n square only, then also this is the ordering. Okay. Is this fine to everyone? Cool. So I hope that is fine. Now let's move to the next question. Okay. Now let's solve this. What is this NC3? n factorial upon n minus 3 factorial into 3 factorial, which is just constant. So this is n into n minus 1 into n minus 2. So I think this is n cube. I mean, in order of n cube. So this is just order of n cube. I don't think it will matter. You can just ignore this. It will not matter. Yeah. So let's just see that what are the answers. So basically you can ignore this. You can ignore this. This is n log n. This is just n cube. Okay. And yeah. So let's just compare. I think this n power log, let's just compare between first n power log n and 2 power n. Which one is greater? N power log n or 2 power n? I think you can take the log. If you take the log, this will be log n. This will log n into log n. So definitely this is greater. So I think F6 is the greatest one, then F5. Okay, this is done. This is done. Now you can compare between the rest. So I think rest is very easy. F1, F4, F3, and F2. Okay. So if you want to compare between these two, I mean, it should be straightforward by, I mean, at this point in time. You can take the log and you can check it. Just try taking the log. So it should be easy enough. See, if you take the log, it will be n into log. It is log n into log n. Okay, sorry. By mistake, I did something wrong. Okay. This 5 is greater. Okay. Okay. Yes. So this is n. This is log n square. So definitely 5 is greater. Yeah. Okay. So 5 is greater. Okay. So they have arranged in the increasing order. Okay. So 2, 3, 4, 1, 6, 5. Let's just read it from the end. 2, 3, 4, 1, 6, 5. Okay. Okay. Just give me a second. Okay. By that time, you can just solve the next question. This one. Okay. So let's now solve this question. For each of the 3 pairs below, we need to rank, right? So let's just rank. I think you can do this is just constant. And this question, I think it's quite easy. You should be able to do it. So I'm just skipping this question. Okay. Should I solve this question or I can skip it? So answers is on the next page. Answers is on the next page. Okay. You can check the answers later. So these questions I'm skipping because the answers is on the next page. You can definitely check the answers later. Right? Let's solve this question. So they are saying this is order of Gn and Fn is this, which means Fn is theta. Okay. So if Fn is theta, so using these two, you can say Fn is theta. Can I say Fn is theta? Let me know. Then do you have this Fn square equal to theta of Gn square? Tell me. Just think about it. If there could be any counter example. See, Fn is just C into Gn. That is for sure. Okay. I mean, Fn is just a constant difference into Gn. That is 100% sure. So even if you take the square, then also it is a constant square, right? It is a constant square. So constant square you can just ignore. So that's why this is also true. I mean, this is true. Now let's talk about it. Fn is this. Okay, I mean Fn is theta. Then are they equal? Yeah, I think we have already solved this question. So they are not equal, right? Yeah, I mean they are not equal. They are actually theta. Fn equal to theta of gn, not exactly equal. Okay, this is saying literally equal. So literally they are not equal. I mean Fn could be just 2n. It could be just n. I mean literally they are not equal, but yeah, they are theta. They are definitely theta. Okay, the second statement is false. Which of the following is or are true? N factorial, yeah, that's interesting. N factorial is strictly lesser than n power n. Strictly lesser. Is this true or false? Strictly lesser. This is true, right? We have seen this. This is true. What about this? Lesser if yeah, that's a good question. Just tell me, what about A is true? What about B? B is saying n factorial is lesser than equal to n power n. What about B? See, if A is true, then definitely B is also true, right? I mean, that is okay. I mean, you are not giving very much. I can say like you are not being too much. You are not giving too much accurate answer, but that is okay. I mean, here you are just saying that either n factorial is less than n power n or it is equal to n power n. So that is fine. I mean, if you are saying 3 is less than 4, you can also say 3 is less than equal to 4. I mean, that's fine. No, Twinkle, you are doing wrong. I mean, if A is true, then B is true, not otherwise. Okay. If A is true, then B is true. If B is true, then you don't know about A. Both are equal. Both can be equal also. If B is true, let's suppose if 3 is lesser than equal to 3, if 3 is lesser than equal to 3, then can you say 3 is less than 3 also? Can you say 3 is less than 3? No, right? No, you can't say. If something, let's suppose if I'm saying that 3 is less than 4, then can you say 3 is less than equal to 4? Why? Why you can't say? This means that either 3 is less than 4 or equal to 4. Equal to 4 is false, that is fine. I mean, if 3 is less than 4, you can definitely say less than equal to. You can put more conditions, but you cannot remove the conditions, okay? Because you are not sure. See, you cannot remove the conditions. You cannot remove this equal. You cannot remove this equal. You can put the equal, that is fine. You can put the equal. Okay, because you are giving the more possibilities. You are saying that I don't know, maybe 3 is less than 4 or 3 is equal to 4. So some wise person will come and he will say that, see, 3 is not equal to 4, but you are actually right because 3 is less than 4. You are saying, see, actually I'm not sure, either this is true or this is true. You are giving more possibilities, which is fine, but you can't restrict the possibilities. Okay, which means you cannot remove this equal. If I say 3 is less than equal to 3, does this mean that 3 is also less than 3? Tell me. No, right? You cannot remove this equal. If someone is saying 3 is either less than 3 or equal to 3, then that some person is right? It means someone is saying 3 is either less than 3 or 3 is equal to 3. Then that person is right. But you can't just say that, okay, let me remove this equal. Okay. I mean, you cannot remove the equal and you can say that this is also true. Okay. Cool. So B is also true. What about this? Do you remember we have seen that log n factorial is in fact theta of n log n, right? If you take the log, then it is theta of n log n. So if that is theta, then big O is possible, but small o is not possible, right? So only C option is false. So A, B, D are the correct answers here. Okay. Now let's solve this question. Rank the given function in order of growth. N factorial power 1 by n and log n power n. It means it is just n log n. And this is n factorial power 1 by n. Now, if you take log both sides, see, this is n factorial power 1 by n. This is n log n. You can take log both sides. That's not an issue. So if you take log both sides, then this will be 1 by n log n factorial. This will be log n plus log of log n. You can ignore this because this is the significant term. So this is log n, and log n factorial is n log n, right? Theta of n log n. So basically you are not doing anything wrong, which means you are just replacing this with n log n. And this is 1 by n. So you cancel it out. This is also log n. This is also log n. So if you take log, if you take log, are you able to come up with any conclusion if you're taking log? Tell me. You can't say, right? So after taking log, you are not able to come up with any conclusion. Why? Because both functions are equal after taking log. If both functions are equal, as we have already discussed this, let me just revise you. See. So if both functions are equal after taking log, then we can't say, right? We can't say. If some function is greater, then we could have said something, but now we can't say. Okay. So here, sorry. Yeah. So here, in this particular case, we can't say. Okay. Now what to do? See, what I did, I have taken the log and I have checked whether two functions are, how these two functions are doing. But after taking the log, I came up with the conclusion that log is not helping. Okay. So we can cancel the common terms, but here actually this is little different question. Here there is no common term also. How to cancel, because it is n factorial, right? So let's do one thing. Instead of this n factorial, I am putting n power n. Can I put n power n? Tell me. Can I put n power n instead of this n factorial? No, I can't put. No, I can't put. See, instead of log n factorial, can I put n log n? Yes, right? Because both are theta. But instead of n factorial, can I put n power n? Okay, I can't put directly. So although I can't put, still I'm putting, which means here I'm just telling you one thing, that I'm putting a function which is even greater than this, right? I'm putting a function n power n which is even greater than n factorial. Okay, just for a moment. Is this okay to everyone? See, this function is already greater than this. And now I'm comparing these two functions. Can I compare these two functions? Just for a minute. Let's forget about this original question. Okay. Let's forget about the original question. I will come to the original question. But for now, let's just compare these two functions. Which one is greater? You will say it is n. This is n log n. This function is strictly greater, isn't it? Okay. This function is strictly greater. So if you compare these two functions, then this right hand side function seems to be strictly greater. Yes. Yes, Piyush. So Piyush is saying 1 is less than 2. Yeah, that is correct. Now let's come to the original question. Okay. In the original question, I wanted to compare these two functions, right? I wanted to compare these two functions. But what I did, I compared these two functions. Can I say that even if I'm putting the greater function than n factorial, मतलब इससे बड़ा लेने पे भी ये छोटा ही रह गया, right? Even if I'm putting the greater function than n factorial, still it is lesser than n log n. तो ये तो छोटा होगा ही. See what I'm saying? Because of the transitivity, you can say, see here this is okay to everyone. Can I say, okay? Can I say this is less than n factorial power 1 by n? right? N factorial power 1 by n. Can I say something like this? Because this n factorial is definitely lesser than n power n. So I can definitely say something like this, right? So if even if you're putting, so what I'm saying here, like, okay, let's say that you are very, I mean, you are not 100% sure about it. So let me just put equal. Okay. Maybe see what I'm saying, that n factorial power 1 by n is definitely lesser than equal to n power n. At least this much you should be convinced. मतलब ये function बढ़ा तो है ही. In any case, that function is greater, right? So even if you're putting the greater function, I mean, you can just see the transitivity rule that even if the greater function is strictly lesser, so this function is definitely strictly lesser, isn't it? So can't I say that n factorial power 1 by n is strictly lesser than n log n? Okay. We cannot ignore the term in the second one and consider it while the comparing logic plus uh, which term we are ignoring? In which question we are talking about? Okay. So basically what I'm saying, that even if you're putting the greater function, that itself is lesser. So that's why this function is lesser, right? Or what is the other way to compare between these two functions? What is the, I mean, more, I don't, so like actually this is a correct way. There is no hack we have applied. This is very much correct way. This is just a transitivity we have applied. So this is correct way, but I can say this is a smart work. But let's suppose there is no smart work that is coming to your mind. Then what can you do? If you are seeing n factorial, then in worst case, what do you need to do? Just apply that Stringlitz's approximation. So what was that approximation? Right? Power 1 by n. Just apply this approximation. Now, if you multiply this is n upon e and 2 pi n upon 1 by 2n, something like that, right? And then this is n log n. Definitely you can ignore this constant. That's fine. This e you can ignore. And then you have to compare between you n and n you can cancel. Then you have to compare between 2 pi n power this 1 upon 2n and log n. I mean, you can do that way also, but I will say that this was the smarter one, right? You are replacing with the greater function, still it is lesser. So why not the original function is lesser? So I will say the original function is strictly lesser than the lesser than this log n power n. Okay. So see, we took log, but after taking we took log. So here you are saying, right? So we can ignore this. We can ignore this because this is in the plus. It's not a problem. If you can ignore the constant, then why you can't ignore ignore this function? Constant is even better thing. I mean, see, tell me accurately. Tell me without asymptotic comparison. Without asymptotic comparison, tell me which one is greater, this function or this function? 2 log n or this one? I'm asking the normal comparison. Which one is greater? What do you think? Obviously 2 log n, right? 2 log n is log n plus log n. This is log n plus log n. है ना? So if you can ignore this 2, then why you can't ignore this log n? This log n is basically, I mean, like even if you over approximate it, then it is log n. And then this is finally 2 log n. And if you are able to, I mean, if you're comfortable with ignoring this constant, then why you can't ignore the lesser significant functions? That's what I'm saying. You're getting my point? So basically, you can definitely ignore this log n. Even if you can ignore, like let's suppose it is 5. Can you ignore this 5? Yes, you can ignore this 5. Then what's the problem in ignoring this log n? If you are ignoring such a 4 log n, if you are ignoring 4 log n's, if it is 5 log n, and if you are just saying it is log n, you are actually ignoring 4 log n's. If you are ignoring such 4 log n's, then why not you are ignoring just 1 log n? That's what I'm saying. Okay. We have not ignored it. अच्छा, अगर इग्नोर नहीं करते तो आंसर आ जाता. No, no, it's not like that. Okay, so let's see method two. In method two, what I did, like I have actually over approximated it. I mean, put the even the greater function in place of n factorial, which is n power n. And then due to transitivity, we are saying that the original function is also lesser, because even after putting the greater function, it is lesser, then the original function is also lesser. Okay, cool. Underestimate करना है कि overestimate? नहीं, n factorial की जगह n power n, I was just putting n power n. I was just trying my luck. Otherwise, if in that case, let's suppose luck won't work. Okay. अब अगर over approximate करने के बाद, if it is greater, then I won't be able to say anything, right? Because in that case, the transitivity won't be coming. So I was just trying my luck by putting the greater function. If that could have not have worked, then what I could have done? I have to do all of this. Okay. I was just trying my luck by putting n power n here. And then I just apply the transitivity. Okay. Okay. If that luck could not have worked, then in that case, I have to do this stringless or approximation. After taking the log, value बहुत छोटा हो जाता है. No, it's not about the value is small or value is greater. You have to check whether it is a function or constant. Okay. If it is a function, then only, if it is a constant, then only you can ignore. If it is a function, you cannot ignore. If it is a function, after taking log or before taking log, if log n into n or something, I mean, even if it is log n, then also you can't ignore this. Okay. So you can't ignore the functions, obviously. You can only ignore the constants. Let's compare between these two. N power 1 by log n. Do you remember there is one property, log base AB 1 upon log base BA? Have you seen those log lectures that we talked about in fundamental videos? Okay, so this is the property, right? So basically you can say this is same as, let's assume log base is 2. This is same as, can I say this is same as 1 upon log base 2n is same as log base n2? So basically this is same as n power log base n2, right? Which is same as just 2. And this is log n. So which one is greater? Obviously log n is greater, right? Yes, Piyush, that is correct. So I hope you are able to do this. So we wanted to compare this and log n. So log n is greater because this function is just constant. This is just constant, which is 2. Okay. If we simplify this, this is just a constant number. This is not even the function, right? Okay. So I think we have solved all the questions, but there are 1 or 2 more questions that I have here in the slide. Just try these questions as an homework. Okay. So these are just, I can say, just bonus questions. So try these questions as an homework. These are easy questions. You can discuss these questions later, but you can just comment out the answer. Okay. Just comment out the answer, whatever the answer you're getting. I don't have the answers, but the questions are easy. Okay. So I don't have the answers here. So you can just try out these questions. So these are the 2 questions. You can take these 2 questions as an homework and try them out. Okay. And comment out your answers. I think here the answers I don't have, right? Okay. For this question, I have the answer. For the second question, I have the answer, which is little tricky also. But for the first question, this one I don't have the answer. It is actually very easy. I mean, we keep on talking about this n and log n. I mean, comparison between n power epsilon and log n power k, right? We kept on talked about this. So basically, this question is based on this concept. So just let me know what is the answer. Just comment it out, okay? Whatever answer you are getting, you just comment it out on the YouTube. So we are going to upload this session on the YouTube. Just comment it out your answer. Okay. So that's all about this particular notations. So I hope all of these questions come, like totally there are 40 questions. So I have took 2 days just to compile those 40 questions, so that neither they're easy nor they are too hard, that is out of gate scope. Okay, I mean, since it is mathematics, so mathematics can be too hard, right? So we don't want to go beyond the gate scope, but we have to understand all the things which are in the gate scope. So I kept the question in such a way that all the things are within the gate scope only. So those questions most probably were able to revise, were able to help you making your concept more strong than before, right? Okay, so now you have one more set, which is stack and queue practice set. Just try out that set. Actually, about this stack and queue, I can tell you one thing, कि in this particular topic, in the stack and queue, there is not much actually. I mean, this is just a definition, right? Stack क्या होता है, queue क्या होता है, there is just definition. So the questions in the stack and queue are actually either that easy, either they're too easy, or generally in most of the question, generally they're too hard. I mean, they are basically related to the aptitude kind of questions. So just try those questions that I have put in the practice set. And it is also very hard to find the good question in the stack and queue. That's what I have realized. So now I'm preparing some material on binary tree, binary search tree, these things. So in 1 day or 2 days, we will be uploading all the videos of binary search tree and binary tree. And I will also be uploading the practice set of binary tree. So I'm thinking that after every topic, we can have a practice set of good question, very good question, not just a random practice set, obviously, right? So that you can have a good revision. Okay, and then we will definitely be doing the PYQs in the video. So there are many good PYQs that I want to solve in data structures, and you will get to see some of the good things in using the PYQs. So in the stack and queue, there are good PYQs. In the heap, in the binary search tree, in almost every topic, there are good PYQs. So we will be solving all the tough PYQs in the class. If it is even easy PYQ, then we might not take it in the class. Reason being is that, I mean, you can solve it even without taking the class. So that's the reason. I mean, it is actually, I can say the opposite of what other people might be doing. So they take the easy questions, just let you feel that things are easy, and then they skip the tough questions. But it's not like that. I mean, at Go classes at least. Okay, so we will be meeting in the next session. So that's all for today, I think, right? So what's the time now? Okay, so thank you, everyone. Take care. Bye-bye.